Okay, so we got two circles. I'm going to be drawing these circles. Okay, and then there's another circle. Okay, so now there is a point of tangency. So there is a hit that is going on like that, and we take this as center. The center, this is the center. And what we are given is, we have to find the length of AB. The radius of the largest circle is 9 units and the smaller circle is 6 units. Figure not to scale. Okay. Now, with this information, what I wish to do is, I would like to connect the two points of tangency with the centers of the circle. Okay, so from here, if I were to drop a perpendicular, let me drop a perpendicular from the center to the point of tangency. Okay. Now, by tangent radius theorem, this will, let me take this as O and this as some P. So by tangent radius theorem, OA will make an angle of 90 degree with the tangent. So there is a 90 degree angle here. Also, PB will make an angle of 90 degree with the tangent. So you connect this, there is a 90 degree angle here. Now, both these angles, angle at A is equal to angle at B is equal to 90 degrees. Okay, so that means these two lines are going to be parallel lines. Okay, so this in turn means OA is parallel to PB. So that is just an observation. Now, since we have got that out of the way, what I wish to do is, I would like to connect the point A, or I would say point B, with a point C. Okay, so from B, draw a line to C. It's just a line to C. Okay, so having got that, what I would do is, these two circles are having a point of tangency here. Now clearly I would take this distance. Say if I were to complete this, that line would pass through the point of tangency. This line will pass through a point of tangency and subsequently connecting the centers. Okay, we are not going to be using this. We are only going to be claiming or using the fact that if this is R and this is capital R, then this entire length will be capital R plus small r. Okay, that is the all important point we will have to come to the understanding. Okay, so since this is R, this entire length is capital R, and subsequently this is going to be from capital R you subtract small r. And clearly CAB, since triangle CAB is right angled, so now what we need to do is we will have to consider triangle BAC. Okay, so we got B here, we got A here, and we got C there. So we'll have to consider this. So there's a 90 degree over here, and AC I just shown you, it's R, capital R, negative R, and BC is capital R plus R, and AB has to be obtained, right? So by Pythagoras theorem we know that AB squared plus AC squared is equal to BC squared. AB squared is required. AC squared is R negative R the whole squared. BC squared is R positive R the whole squared. You expand this, you get R squared plus 2 times R positive R squared. You bring this to the other side. So it's going to be negative of R negative R the whole squared. So this is R squared plus 2 times R plus R squared. You expand this, you get negative R squared and positive 2 times R. So negative R squared, positive R squared, negative R squared, positive R squared goes away. You have 2 times R, positive 2 times R. It's going to be 4 times R. Okay. Now what is this? This is my AB squared. So AB is equal to square root of 4 times RR, which is nothing but 2 times of root of capital RR. Now since R is equal to 9 units, small r is equal to 6 units, so it's going to be 2 times the root of 9 into 6, which is 2 times the root of 9, I'll have it like that, times root of 6. Root of 9 will give me 3 units, and this is 6. So 2 times 3 is 6 into root of 6 units. Okay, it's just units. So what is this? This is my AB. Okay, so that is the conclusion of this lovely question. Thank you everybody.